I am K. Omeswara, Department of Physics. Today my topic is third sem, Unit 2, Thermodynamics. Very most important question. Explain the working and efficiency of Carnot engine. So, Carnot engine in 1824, Sadi Carnot thought of an ideal engine. So, Sadi Karan imaginary and illusion in first of all 1824 ideal engine. So the Carnot engine, like heat engine, consists of these four consists of number of parts. For first one, working substance. So this is the total piston. So this is a piston. So this is a cylindrical shape piston. So next one, working substance. So let us consider 1 mole of ideal gas in working substance. So these all gas in 1 mole of ideal gas. So next, the walls of the cylinder are insulators. So this is walls. This is walls. This walls consist of insulators. So does not flow of heat is called insulators. So next, the bottom of the cylinder is conducting. So the bottom. So this is the bottom. The bottom of the cylinder consists in conductor. So flow of heat is called conducting. So this is consist of conducting. So next, the piston is non-conducting and frictionless material. So this is the piston. So this piston is consists in non-conducting material and frictionless. So piston means up and down. So this up and down moving in to and fro. So that is a frictionless piston. So next, second part, insulating stand. So this is the insulating stand. So this is a insulating stand. So it is a non-conducting material. So this insulating material consists in a non-conducting material. Next, itself of working substance are adiabatic chains. So non-conducting material insulators in adiabatic chains. So these are adiabatic chains. Next, third one, sink and source. Source. So this is the next one. So source. So it is maintained at a high temperature. High temperature. High temperature. So next one, it is heat reservoir. It is a heat reservoir. So this is the source. Source temperature indicates the T1. So it is a high temperature and it is a heat reservoir. Next, it is high thermal capacity. So it is a high thermal capacity. So that means this is the source high temperature in T1. For example, this source will be temperature 1000 degrees centigrade. So some amount of heat removed, so does not change in temperature. Some amount of means 200 degrees Celsius temperature are removed, so does not change in this temperature. So what temperature? 1000 degree Celsius temperature. So source working substance source working substance heat absorption. Heat absorption. So this is the source. Third one, source maintained at T1 high temperature. So it is maintained at high temperature T1. It is heat reservoir called a source. It is a high thermal capacity. High thermal capacity means, for example, source is the maintained at 1000 degree Celsius. So some amount of heat removed, so does not change of source temperature, is called thermal capacity. Next, source working substance heat absorption. So next one, sink indicates the T2 degree Celsius. So it is maintained at lower temperature, indicates the T2 degree centigrade. So sink is maintained at lower temperature. So this is the sink. So this is maintained at lower temperature. So another name, it is colder reservoir. So it is the colder reservoir. Source is heat reservoir. So sink is colder reservoir. It is high thermal capacity. So that means, so colder reservoir or sink maintained at T2 degree centigrade. So these sink temperature is 0 degree Celsius. So adding with some amount of heat, so does not change in these sink temperature, is called thermal capacity. So does not change, some amount of heat is added in the sink, so sink temperature is does not change, that means is called thermal capacity. Next, sink substance sink working substance, sink working substance, heat reject, heat rejects. So heat is rejects. This is the sink working substance. Next, next one, working and efficiency of Carnot engine. Carnot engine. So working and efficiency of Carnot engine. So Carnot engine means Carnot's engine. Carnot engine means a reversible heat engine operating between two temperatures. Is called Carnot's engine. So this is the diagram of Carnot engine. So x-axis taken as value V, y-axis taken as P. So this is the point P1, V1, T1, P2, V2, T1. So next P3, V3, T2. Next P4, V4, T2. So this is the reversible heat engine. Reverse A, B, C, D, A to B, B to C, C to D, D to A. Reach the A. So that means reversible heat engine operating between the two temperatures. So this is the isothermal expansion, IE. Isothermal expansion. This is the adiabatic expansion, AE. This is the isothermal compression. This is the isothermal compression. Next, this is the adiabatic compression, AC. So isothermal, adiabatic. So operating between the two temperatures. One temperature is isothermal, second temperature is adiabatic temperature, is called Carnot engine. Next one, Carnot cycle. Carnot cycle. Next one, Carnot cycle. So A heat engine is to be operated in a cycle is called Carnot cycle. So a heat engine is to be operating in a cycle. So this is the cycle wheel. So cycle is called the Carnot cycle. So Carnot cycle follow the steps. There is following steps. So the following steps in 4 steps. So 4 works W1, W2 and W3 and W4. So there are first step 1, following steps. Step 1, isothermal expansion. First step, isothermal expansion. So isothermal means temperature is constant. Thermal means temperature is constant. Remaining variables are changed. So temperature is constant. Remaining variables are changed. So isothermal expansion means temperature is constant. Thermal means temperature is constant. Remaining variables are changed. Remaining variables means pressure and volume. So first let us consider says that P1, V1, T1. So pressure P1, volume V1, temperature T1. It is the says that. So isothermal expansion. So this is the isothermal expansion. So isothermal means temperature is constant. So temperature T1. So temperature is constant. Remaining variables are changed. Remaining variables means P and V. P1, P2, V1, V2 changed. So isothermal expansion working equation P1, V1, T1 to P2, V2, T1. So this is the change. Temperature is constant. Remaining variables P1, P2, V1, V2 changed. Working equation W1 equal W1 first work W1 equal N of T log E base V2 by V1. So this is the first equation. So W1. So temperature is constant. So temperature means T1. So that means T1. N means number of moles. R means gas constant. Log E base V2 by V1. V2 by V1. V2 by V1. This curve is called isothermal expansion. So this is the equation. So temperature is constant. Heat, some heat Q1. So next, second step, adiabatic. Adiabatic expansion. Next one, adiabatic expansion. So adiabatic expansion. Adiabatic means heat is constant. Heat is constant, remaining variables are changed. So this curve is called adiabatic expansion. Adiabatic means heat is constant. Heat indicates the Q. So Q is does not Q. So P2, P3, V2 change in V3, T1 change in T2. Heat is constant, remaining variables are changed. Remaining variables means P, V, T. So P2, P3, V2 change V3, T1 change T2. So point P2, V2, T1 to P3, V3, T2. So work done, W equal NR by gamma minus 1 into T1 minus T2. This is the equation number 2. So work W2, work W1, W2. So heat is constant. That means temperature is changed. Temperature T1 to T2 changed. Temperature is constant. Heat remains changed. So that means heat is Q1. So heat is constant. So constant means 0. So 0 equal to Q2 means 0. Q2 means 0. So 0 equal W2 equal to NR by gamma minus 1 into T1 minus T2. This is the equation number 2. N means number of moles, R means gas constant, gamma means specific gas ratio, T1 and T2 means temperatures. So next, step 3. Step 3, isothermal contraction. Compression or contraction. Isothermal contraction. Step 3. So isothermal means temperature is constant. Remaining variables are changed. That is the isothermal contraction. So isothermal contraction means this curve is called isothermal contraction. So P3, V3, T2. P3, V3, T2 to P4, V4, T2. P4, V4, T2. So temperature is constant. T2, temperature is constant. Remaining variables are changed. P3, P4, V3, V4. So P3 changes P4, V3 changes P4, temperature is constant. So work done equation, so third step, that means third work equal nRT log E base V4 by V3. So V3, nRT, T means T2, T2. So T2 log E base V4 by V3. V4 by V3. So first step is isothermal expansion. So third step means isothermal compression. Compression means this is the compression. So this is the compression. This is the expansion. So that means indicates the compression and expansion means negative. So negative sign indicates the compression and expansion. So minus nR T2 log E base V3 by V4. So this is the V4 by V3, V3 by V4. That means whole inverse. Whole inverse means minus log. So that means minus. So isothermal means temperature is constant. Heat remains changed. That means heat indicates the Q. So this is the Q2. So equation number 3. Step 4. Adiabatic compression or contraction. So adiabatic contraction means heat is constant. Heat is constant, remaining variables are changed. So remaining variables are changed. So adiabatic compression or contraction. So P4 V4 T2. P4 V4 T2 to P1 V1 T1. So to P1 V1 T1. So heat is constant. So heat means indicates the Q. So does not Q. So remaining variables are changed. Remaining variables means pressure P4 to P1, volume V4 to V1, temperature T2 to T1 are changed. So work done equation W equal nR by gamma minus 1 into T1 minus T2. So gamma means specific gas constant, N means number of molecules, R means gas constant, T1 and T2 means temperatures. So temperature T2 minus T1. So T1 minus T2. So W equal, so fourth step, that means W4. W4 equal nR by gamma minus 1 into T2 minus T1. That means minus nR by gamma minus 1 into T2 minus T1. So this is the equation number 4. So this is the T2 minus T1. That means T1 minus T2. So T2 minus T1. So adiabatic compression, adiabatic expansion. So reverse T1 minus T2. T1 minus T2. So common term is negative sign. So minus NR gamma minus 1 into T1 minus T2. So this is the equation number 4. Heat is constant. That means heat means Q. Q means constant 0. So 0 equal to omega 4 equal to minus NR gamma into T1 minus T2. Next. Next, total work. Total work. Total work done. Total work done. W equal W1 plus W2 plus W3 plus W4. W4. Are you remembering? W1 means NR T1 log E base V2 by V1. W2 means NR gamma minus 1 into T1 minus T2 plus W3 means minus NR T2 log E base V3 by V4. So this is the third equation. Third equation W3 equal to minus NR T2 log E base V3 by V4. Next W4. W4 minus NR by gamma minus 1 into gamma minus 1 into T1 minus T2. T1 minus T2. So this is the W4. So W equal to same terms NR by gamma minus 1 minus NR by gamma minus 1 T1 minus T2. T1 minus T2. So these terms are cancelled. Remaining equation NR T1 log E base V2 by V1 minus NR T2 log E base V3 by V4. V3 by V4. So W equal NR T1 log E base V2 by V1 means Q1. Step 1 Q1 isothermal expansion, isothermal compression or contraction minus this is the term to Q2. So this is the working equation. Next efficiency, Carnot engine efficiency. Efficiency indicates eta. This is the eta. So efficiency indicates the eta. So the ratio between work and heat is called efficiency. So eta equal, therefore eta equal W by Q. Q means heat, so indicates the Q1. So this is the efficiency. That means W means Q1 minus Q2. Q1 minus Q2 by Q1 by Q1. Q1 minus Q2 means NR T1 log E base V2 by V1 minus NR T2 log E base V3 by V4 whole by Q1. Q1 means NR T1 log E base V2 by V1. So next one, 2 and 3 adiabatic process. So the relation between the temperature and value. The relation between temperature and value. That means T1 V2 power gamma minus 1. So this is the temperature volume relation. So pressure and volume relation of PV power gamma equal to constant. This is the pressure and volume relation. So this is the temperature and volume relation equal T2 V3 gamma minus 1. So 2 and 3 adiabatic process. 2 means volume 2, 3 means volume 3. So next 1 and 4 adiabatic process. So that means T1 V1 power gamma minus 1 equal T2 V4 power gamma minus 1. So 1 means volume V1, 4 means volume V4. This is the temperature and volume relation. TV power gamma minus 1. So these both equations, this is the equation number 5. This is the equation number 6. So these two equations from 5 by 6. So T1 V2 gamma minus 1, T1 V1 gamma minus 1. So T1 V2 gamma minus 1 by T1 V1 gamma minus 1. So 5 by 6 LHS and RHS T2 V3 gamma minus 1 by T2 V4 gamma minus 1. So T1 cancel, T2 cancel. V2 power gamma minus 1 cancel. V3 gamma minus 1 cancel. Remaining V2 by V1 equal V3 by V4. So we substituted in this equation V2 by V1 means V3 by V4. So V2, V3 by V4 means V2 by V1. So V3 by V4 replaced in V2 by V1. So this equation eta equal N0T1 log E base V2 by V1 minus N0T2 log E base V2 by V1 replaced in V3 by V4 means V2 by V1. V3 by V4 means V2 by V1 whole by N0T1 log E base V2 by V1. So next common terms in eta equal common terms NR common log E base V2 by V1 log E base V2 by V1 log E base V2 by V1. So remaining T1 minus T2 whole by, so NR log V2 by V1 into T1, NR log E base V2 by V1 into T1 minus NR log E base V2 by V1 into T2, NR log E base V2 by V1 into T2. So whole by same NR log E base V2 by V1 into T1. So NR log E base V2 by V1, NR log E base V2 by V1 into T1. So these two terms are cancelled. Remaining equation eta equal T1 minus T2 by T1. So that equal therefore 1 minus T2 by T1. So this is the efficiency of Carnot engine, or eta equal 1 minus temperature means heat Q2 by T1 means Q1. So this is the equation of Carnot engine. Okay, thank you friends.